Birdhouses. Jennifer makes birdhouses to sell online. A small birdhouse requires 1.5 feet of wood and 3 hours of labor, while a large birdhouse requires 3 board feet of wood and 5 hours of labor. She makes a profit of $9 for each small birdhouse, $3 for each large birdhouse. And Jennifer wants to make a profit of at least $84, and she wants to use at least 54 feet of wood. How many of each should she to minimize her labor? Okay, so here we want to minimize time, which is also really common. So we want to minimize time. That's pretty common. Usually you want to minimize time, maximize profit. That's usually the biggest goals here. Okay, so we have small and large birdhouses that we want to think about. For a small birdhouse, it takes 3 hours. And for a large, it takes 5 hours. And we want to minimize that somehow. It looks like we're going to have to set up a money inequality. So $9 for the small and $3 for the large. And we want to make at least $84. And this is the one I don't fully understand. I mean, I know how to set it up, but I don't fully understand why we'd want to use at least this much material. Oftentimes we'd want, I would think, kind of reduce the amount of material, but maybe it's just the silly math problem part of it. But we have a wood board feet that we want to satisfy. 1.5 for the small and 3 for the large. And strangely, to me at least, until someone can explain it to me, we need at least 54 feet of wood. But I would think we'd want to minimize that too, but not for this problem, I guess. I don't see any other boundary conditions other than the fact it has to be positive. So I would say small and large have to at least be 0. They can't be negative. They can't be negative. Okay, I think that's all we need to set up the problem. And our technique is to graph it to find the corner points. See if we can do that. Whoa. I'll call this small. I'll call this large. I need to find my intercepts. So what would my intercepts be? For my money equation, I have 84 divided by 9. Small equals 9.3 repeating. And 84 divided by 3 is 28. And then 54 divided by 1.5 is 36. 3 is 18. And I have to be in the first quadrant. I think that's all we need to graph to solve the problem. Okay. I think I will just graph this by tens. Nothing actually lands on the 10, but I think I can get close enough with that. So if that's 10, that's 10. That's 20, that's 20. That's 30, that's 30. And that's 40, that's 40. I think that should be close enough for me. I hope. Okay. I have a point that's not quite 10 and it goes up to not quite 30. So I could say here and not quite 30 would be here. Something like that. And my other point is a little bit it's in between 30 and 40. Something like here. And then also not quite 20. Be something like here. Hopefully I'm not stuck in that region. Otherwise I might have to draw another graph. Something like that. Okay, now I need to see which direction out of those lines. Hopefully my graph is good enough to at least point me in the right direction for corner points, but this is the thing I struggle with personally the most. Yeah. But we only need the graph to just point us towards where those corner points are. Anyway, let's see if 0, 0 works. If I plug in 0 plus 0, is that greater than 84? No, it is not. So I know I'm going away from the origin with that one. All right, that was this one, and it's saying you want to go that way. Okay, the other one, 0, 0, doesn't look like it works. 0 is not greater than 54. That can't be right. So it says go away from the origin. You don't want to go that way. Okay. So I have to go the other way. That means that I think I just found my region. I think I'm going that way. I think. Okay. I think I'm going that way. Where are those corner points? Looks like there's a corner point here, here, here. Okay. I know 2 out of 3. I know some of those. That is 28. I don't know that one. This one was 36. So I know those. It's that one where they intersect that I'm not sure. I don't know where that is. I can find it, but I don't know where it is. Okay, so I need to find that. At this point, I'm not sure where that's located. It seems like S is less than 10 and possibly less than 20, but that depends on how good my graph is. Okay. All right, so let's find it. That's when they intersect. So I have 9S plus 3L equals 84. And I have 1.5S plus 3L equals 54. And I want to solve for both of these variables. At least with my numbers, I have equal large right here. I have 3, 3, so they're equal. If I subtract them, they'll be equal and opposite. Okay. So that's 7.5. That goes to 0. And that's just 30, right? So I get small birdhouses is 4. That's less than 10. That's about all I knew. And how many large birdhouses then? 9 times 4 plus 3 times L equals 84. And so that would be 84 minus 36 divided by 3, which is 16. Okay. That's that other corner point. Let's not celebrate quite yet, because now we have to find what corner point is the right one. We have 0.28. We have what I think is 4.16. And we have 36.0. And we have to test them. Okay. So this one would be 5 times 28. That's 140. And this is 4 times 3 plus 5 times 16. 92. And 36 times 3 plus 5 times 0. Okay. So we wanted to minimize it, and that looks like it's 92 to me. So the minimum hours would be 92, and that occurred with 4 small birdhouses and 16 large birdhouses. I don't think I can't do that. Question. What's the hardest part about this problem? Is there anything that's particularly difficult?
I understand the graphing, but it's just hard, like, to get it right.
That's my weakest link right there. If I mess up on that graph, which the graph is only to tell me, point me in the direction. I got the solution and it just said it's right here. It's one of these. I knew so the only point of the graph was to be like, look there.
Yeah.
But I don't know how else to do it. If I don't do any graph, I don't know where to look. And I can't do it well enough in my head just to say, well, this is true, so we're not here, here, or here. But there's 4 regions it could have been. And I can't see it clear enough. So I need something to do it. So yeah, I'd say the graph is probably the easiest thing to mess up. And if we mess that up, then we might mess everything up. So that's our weakest point. With the homework, you can of course check with a graphing calculator, and that's a good reference. And the thing I've found for myself is if it's an empty set, my hand-drawn graph is very difficult. Like, I'm very likely personally to mess up if it turns out there's an empty set there when I graph it by hand. I'll kind of naturally want to fill it in somewhere. So there is no maximum, but there is a minimum, and so we can keep going up. There's no maximum. You can just keep going up, 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 up. So you can spend an infinite amount of time to make an infinite amount of birdhouses, but not a minimum. There is no max. Online folks, does this make sense? Is this clear?
Yes, sir.
You can tell me now. If it doesn't, you can explain again. You're welcome to say it doesn't make sense.